Okay, Webster 2. Pages, it was a great group, but given the pressure we were under, there were some real growing issues. The team was threatening to fall apart. And two things sort of saved that. First, Rick Gessner, one of the engineers, had some training in conflict resolution. And we basically did a private series of team meetings in which he basically said, this is an effective way to disagree with someone, this is an ineffective way to disagree with someone. In terms of language, I mean, it's stuff that's not necessarily novel, but it really helped. Because we agreed as a team, okay, there are things there's types of languages we will or won't use in disagreeing vehemently with each other. And in resolving conflicts over technical decisions. The second thing was one that, as far as I recall, I came up with this on my own. But I have seen the same or very similar techniques written up places. I took the whole team to an offsite. We went to, rented a conference room at some hotel closer to the beach. This is in San Diego. And actually got a big whiteboard and did this meeting in an open air patio, so it was nice, you know. Nice San Diego weather. San Diego has great weather. Nice San Diego weather, cool, you know, cool breezes coming in from the ocean, away from the pressure cooker of the offices. And I asked each developer, I said, why are you here? What is the most important thing that you want to get out of working for Pages, personally and professionally? And we wrote all those on this big whiteboard. So by the end of this exercise, all of us knew exactly why each of us was on that team, why we were at Pages, why we were working 70 hours a week, why we were ignoring people trying to recruit us away, and so on. And then we had an open discussion. I said, we need to come up with a set of 3 or 4 basic team goals for us as a team, not as a company, but for us as an engineering team, that will help all of us to achieve our individual goals. And that was a very interesting discussion, because you started to have engineers proposing goals that were specifically designed to meet the personal goals of other engineers on the team. That was a tremendous bonding moment for the team. And we probably spent a good hour or two on that, because it's kind of like, oh, what is this, and so on and so forth. But I made it clear, none of this has to do with the company. This is simply us as an engineering team. And then, once we had that list of goals, the last discussion point we had is, how can we make our team goals align with what the company needs done? And we had another hour or two discussing that. We made some tweaks to some of the team goals. But by the end of that day, every one of us on the development team could see how the other team members were helping each of us to achieve our personal, whether it's professional or technical or just personal goals, and how, as a team, we were helping the company to succeed. The problem is you don't often see this. Again, and this will be in Webster's 3, which we'll get to after we do our break. Management often has sort of a ditch digging approach. Software engineering. We need a ditch 6 feet deep, 10 feet wide, 100 yards long. We need 20 people to do it. If we get 30 people, we'll do it in 50% less time. That's not how software teams work. Software teams are very sociological, they're very creative, and they sometimes get to some of our deepest goals and aspirations And to the extent that we are ignorant of or disdainful of the goals of others, teams can fall apart. When we read Peopleware by DeMarco Lister, which is going to be the next book we're going to start on after today, you'll notice something. They talk a lot about teams. They talk about how to help teams gel, but they frankly admit you can't make a great team. A great team has to form on its own. They'll also say, however, it is possible to kill a team. And they'll say it's not that most organizations are designed or intend to kill good teams, they just act that way. And it's true. A lot of standard management practices will destroy or cripple good software teams. Has anyone had this experience with any of this as far as aligning goals within a software development group? Again, this happened for me. This was in the early 90s, so it's like 15 years after I left college. It was a while before I copped to this. Okay. Yes?
Well, what's an example of like a goal that you establish with your team, like, or the types of goals that you would establish?
Well, for personal goals, it was things ranging from I want to win the geek lottery. That is, I want the company to go public or get bought up, and for all of us to have shares and get lots of money. It could be I want to build cool software. I want to ship software that I'm proud of. I really want to become an expert in this technology, and so on. As a team, you then have to say, okay, what's going to be required to achieve all these? Well, we're going to have to build great software. It's going to have to be successful. It's going to have to be good enough to attract the attention of both end users and or a potential buyer. We have to keep the company viable long enough for that to happen, stuff like that. So those are some of the team goals. And of course, the company's goal was to become profitable and then either go public or get bought up. Sadly, we picked the wrong platform and ran out of money. That happens a lot. Seemed like a good idea at the time. Let's pause here. Let's take a 7-minute break. We'll go use bathrooms, and then we'll continue this lesson. We'll take a roll after the break. Bye, sit down. Last few comments on this slide. At Pages, we had 0 voluntary turnover for 4.5 years. We never had, despite the very, very long hours for extended periods, we never had a single engineer leave voluntarily. We had one early hire that I fired after a month. We had one other hire who we fired after about 2 years, and he just became too disruptive for the team. We had 2 who were laid off about 4 years into the project, just because we're running that way. But we had basically 0 turnover. Now, the problem, as I said, we're going to talk about this more with Webster 3, is that upper management tends to see engineers as interchangeable components. Can't we just hire a few engineers? That's a bit like, you know, an NFL team saying, well, we just need a couple of defensive tackles. Of course, you know how much screening they go through and tryouts and everything else. And then sometimes they hire them and they don't work out. It's kind of like, well, that was a bad acquisition because, you know, they didn't work out, or, you know, he just got a high ankle sprain, he's out for the next 3 weeks, and so on. I think I've already quoted one of our engineers when we were trying to get all this motivation from management after 3.5 years of working our butts off, and one of the engineers saying, don't they realize they're dealing with grown-ups? There just really is, and it doesn't happen in all organizations, and technology-oriented organizations, it doesn't tend to happen at all. When you go to work for a corporation or even some software houses and so on, there tends to be a disconnect between business-related management and the technical people. Any observations on any of this before we move on? I always find I get less questions as further along in the class we go. Okay, Conway's Law. I think I've already mentioned this to you when I did that $500 million project review. One of the things I wanted to see is what was the architecture prior to put together. There was no chief architect. $500 million project, $500 million spent. Wasn't done yet. There's no chief architecture and there's no coherent architecture. This is what kept coming to mind while I was trying to trace out the various components that are supposed to work together. Conway's Law, you should have read by now in Mythical Manma. Brooks coined the term, but the author was someone else. Basically says, the architecture of a system is usually a reflection of the organization that built it. And the problem at this place where I did this review was that even though this was supposed to be this grand unified system, it had been chopped up in so many ways, both horizontally and vertically, and not always consistently, that it was just the architecture was a mess. Yes?
Sorry, this is a little bit off topic, but I know you can't really say anything. Did they end up finishing the project?
To what I know, they spent a couple $100 million more and they put some small components of it into production.
Okay.
That's pretty much what they got for about $700 million. Oh man, it was, and I can tell you that the firm, not due specifically to this, so I'm sure this was a contributing factor, but because of some other accounting irregularities, the firm, which was trading in the 90s, $90 plus a share when I was there in the 90s, ultimately was delisted from NASDAQ.
Just follow up. How much do you think that, like, you know, some cost fallacies play into these things where companies end up dumping like $500 million into something?
That's a good point, and we'll take a second on that, because this is an issue that I see all the time in these failed lawsuit projects. My mantra after 25 years of reviewing failed projects is that most projects need to fail faster. The project should be pulled much sooner, but the sunk cost is, well, we've already spent $100 million. You know, we have to get something for it. So they end up spending $200 million and they don't get anything for it. This is so common in software. They will keep spending and keep spending and keep spending, hoping that at some point the magic lights will go on and it'll all go live and they'll get some benefit out of it. Often it will go live, but when they do, it is very underwhelming and frankly not a very good return on investment for the money they put in. It's much worse. They don't get the benefits they want out of it. And other times it just finally gets the plug pulled. So there is a real reluctance to pull the plug quickly, and my advice almost always is they should have pulled it sooner. Yes?
So it's not always management's fault, right? Like I've had some experience where the programmers get too religious about their own code.
Oh yeah.
And so
That's a whole other set of issues. It's kind of like just
management. It's these programmers that want to continue what they build. Have you ever, like, what's the issue? How do you deal with that?
that's the taking the door away from them. That's where you need a good project manager who says, we're building X, get these features in place, we're going to take it away from you. If you don't have someone, this is why you have the project manager be someone different from the chief architect. You need someone who can basically say, stop, this is what we're building, this is as far as we're going to go. At Pages, now one of the great things at Pages about being late was that by the time we realized we were going to be late, we had already done the user manual. I should bring it in. You know, 3-ring bound manual back when people did physical manuals. Great color plates and so on. So we actually had this done months and months and months before we ended up finally shipping. And our CEO, Larry Spellhog, did a brilliant thing. He basically got copies of that manual for everyone in the company, he put them on our desks, and he said, if it's not in the manual, don't build it. And that was the mantra. It's like, you know, anytime any engineer said, well, you know, we could do this cool thing, Larry would say, is it in the manual? Well, no, he said, don't build it. We're building what's in the manual here. Anything else gets pushed off one point. So yes, it can be, I agree with you, it can be an issue where you have coders who are basically riding a hobby horse or who insist on, you know, technological purity or whatever. And again, to quote Steve Jobs, real artists ship. If you're a great coder, you ship code. You don't work on it forever. Yeah.
As far as Conway's law, when we were organizing our,
Teams.
yeah, it seemed like a mixture of the organization of the team and an organization of who's going to do what and together who. It seemed easier to say fit the requirements so that we can split them up amongst the way that we are organized.
Yeah. But make sure that's going to be the architecture, the requirements you're actually going to implement. But yes, the whole point is that your team organization should actually fit what you're building. And one of the things we'll read about in Accelerate is that this actually gives you a certain way around Brooks' Law. That high-performing organizations tend to build loosely coupled architectures, where you have chunks that internally have tight cohesion, but have only loose couplings via, say, APIs to each other. And by doing that, you can add teams, or add people to a particular chunk, and it doesn't affect all the other chunks. They're all, the more that they are sort of standalone in how the architecture and design is set up, the easier it is to add and remove people without impacting the overall project. But if you have, everyone has to talk to everyone else, and each new person you add adds a real burden. And we just talked about all this. So, and most of you have small enough teams, and frankly, you already did a lot of this division. Sort of like, okay, here's front end UX, here's back end, and here's our project manager and chief architect, and that's pretty much what a lot of your teams work. But keep this in mind as you're doing your requirements document, and then in 2 weeks we'll lecture about your architecture and design document. That you may want to do shifts as you do that. Yes?
So your statement here puts simply architecture tends to follow organization, not the other way around. Is that also trying to say you should design your architecture and then your organization needs to be reformed or whatever to fit that?
Yeah. In other words, often what you have is you organize a team and you start to build it, and the team is set up in such a way that the resulting architecture is suboptimal. But you don't realize that. You keep trying to sort of shoehorn it in or whatever. So what you want to do is figure out what your overall architecture is, and then organize your team to optimize that. Any other thoughts or observations on this? Actually making pretty good time here. It's not going to drag out as long as you feared. Okay, controlling IT costs using a maintenance architect. We're not going to spend a lot on this other than that this remains a point of pain for organizations that have existing systems, particularly when you're talking about corporate organizations, NGOs, government organizations, and so on. That you have all these legacy systems in-house and no one really understands them. This was a proposal I made in this article for Baseline, that in essence you should appoint, this is a great training area for a potential chief architect. Now, if you already have a CTO and or a chief software architect, and you have someone that you want to sort of prepare for that kind of role, have them become a maintenance architect. Have them actually study your legacy systems so that they understand the architecture of each system, and, as is usually the case in large organizations, how these systems interact with each other. That'll do a couple things. First is it will improve the quality of your maintenance work. When you want to add new features, because right now what happens with maintenance, there's usually one of two things. First, you either have someone who's sort of entrenched and he or she is the System X expert. And all they do is work on System X, and if someone says, we need to add these 3 features, System X, like, I'll do it. They do it, and you have basically no insight as to how it's being done, and then that person retires or changes jobs or gets hit by a truck, and no one has a clue as to how System X works. and they go in and try to figure it out, and the code is a mess. How many of you have, in internships or jobs, have had to inherit someone else's code? Yeah. How easy is it to pick up and read someone else's code? Now there are places where I've looked at code and it's excellent. Where it's like, oh my gosh, someone did a really great job on this. But boy, I'll tell you, that's not the rule. That's the exception. Yes.
This last May, I started on the IT department's MyLink project, which is BYU's education major website. And it was written by students like 10 years ago in PHP. And it was the worst collection of code that I've ever seen before. And even the full-timers complained about it. And that's what we're doing, or they're going to do V2 this year. And it was horrible. And there was no management looking over these students that did it. So.
And this is where you get software rot, software entropy, because usually they say add these 3 features and you basically do whatever it takes to make that work, just so you can get out from that code. And the code becomes less, the whole conceptual unity becomes less and less conceptually unified. It becomes a collection of hacks and kludges and fudges, and each new person adds something and it becomes less and less stable as you go along. It's harder to fix bugs. They say, go fix this bug. You start to trace the bug. It's like, oh my gosh, I've got to change 12 different routines to fix this one bug. This is I've seen a lot of heads nodding, so obviously a lot of you have had that experience. So this is something that I think organizations should do. I don't know how many actually do it, but it's something to keep in mind as you move out into industry. Sort of keep this in your back pocket. That if they're going to make you do maintenance, say, hey, how about if I become a maintenance architect and I basically document all our existing, understand all our systems we're maintaining, and document them so that we can make changes. They may nod their heads and say, yeah, you do that. At which point you're not an expert on one system, you're expert on all the legacy systems. And then they start coming to you and saying, well, we're adding this new system. You say, well, look, if you add that, it's got to interface with this system, and this system, but they have 3 different requirements, so you're going to have to do this, and they become impressed with you. And you get a promotion. And they lived happily ever after. Let's see here.
Become completely permanent as a required, like.
Oh yes. You can. That's a great way to sort of like a tick burrow yourself in, and they don't dare get rid of you because
You're not in one legacy system, it's all of them.
Yep.
Like, these dies, they can't.
Yeah.
This dies.
Okay, negotiations and Lovesongs. I should finish this up. This is a very short article I wrote, but it struck me during one of my project reviews. And there's not a lot new here, other than, actually I know when this hits me. It hit me watching. How many of you saw A Beautiful Mind about John Nash and the Nash equilibrium? And it suddenly hit me, my gosh, game theory has a great application in software development within an organization, because you have at least 3 major groups. You have the people doing the work. You have, and sometimes that's divided between the programmers and the system administrators. And they often are cross purposes. But right now, we'll lump them together. So you've got the engineers, you've got upper management, and you've got the actual end users within the company, organization that have to use it. And they all have very different priorities. As I say in the article, it's not only that they can't agree on the rules, they're playing 3 different games. The classic, how many of you have been in a software development in a situation where you're adding features to a product and you're having to deal with marketing, selling it? What does marketing tend to do? Lie. There's actually an old joke about what's the difference between a used car salesman and a software salesman. The difference is a used car salesman knows when he's lying and knows how to use his product. So with marketing types, and I have good friends in marketing, but I've also had shouting matches with those same good friends. It's like, you promised what? We can't do that. Well, we have to do it. No, we can't. We literally cannot not do that. Our software does not do that. And then end users. End users hate change. This is back to my story about pages. You know, we do this, what we think is a groundbreaking, object-oriented, drag and drop, just a publishing system with automatic design, and the first complaints we get are, you know, we want a ruler and we want WordPerfect and Emacs to keep bindings. What, don't you understand the greatness of what we built? It's like, no, we want WordPerfect great, or I'm sure someone at end, Emacs to keep bindings. These three groups tend to be at odds within an organization. And even when you're talking about commercial software, so you're talking about customers instead of end users, they can often be at odds. How many of you find yourself swearing when a new version of iOS or Android is pushed out to your cell phone or tablet and it just changed some user interface aspect or some other behavior? It's like, why did they change that? It worked just fine before, it's wretched now. I am profoundly disappointed with Apple. I have more complaints with each new version of iOS that gets pushed out. There's just, anything. So, the thing to realize here is that you're going to find these are the three groups that are at odds when you go into a software development situation. And along those same lines, if you happen to go to work for an outside development firm, or if you go to work for a firm that's selling a product into an organization, these are the three groups you have to convince. In other words, let's say I've got some nifty enterprise software product and I want to sell it to Corporation X. Okay, I've got to convince management that they get a return on investment, it's fine. I've got to convince the IT department that they should support this and integrate it with all their other systems. And I've got to convince the end users to give up their old system and to use our software instead. And I've seen projects fail on any of those three. So be very much aware of this. Anyone have any horror stories or yeah?
When I was at my internship and we were working with changing the whole testing framework, I don't know why. It was an internal product, right? Testing framework. But I got dumped with the job of teaching other teams how to use the testing framework. So like, there were a couple days I had to come at like 4 o'clock in the morning and talk to some people like in Europe and stuff. It was really weird. The thing is like everybody just didn't want to change because they had all used this previous testing framework, which worked just fine. I actually agreed with them there, but yeah. So they're like, we're using this new one now. I'm like, yeah, but what the new ones?
I may have already mentioned the story. This was a failed project lawsuit I was involved in where this company was a personnel placement company, placing medical personnel. And their legacy system was this monolithic system that had been developed by this old school Unix programmer. It had it for like 10 years and been patching it forever. And the company brought in a well-known mid-sized consulting firm to basically put in their accounting software, and then it was one of these accounting packages where they can add all sorts of code on it. They're doing this other stuff. And they got this classic statement. The end user said we want it to work just like the old software, but better. And one of the things that some of the end users, the ones with the most power, and you'll also discover among end users there are some that have more power than others, particularly office managers and department secretaries, if they're the ones using the software. The old system only did everything in uppercase. It was simply written that way. Never used lowercase letters anymore. So this company is putting in their current state-of-the-art stuff, and this one end user demands that everything she typed be in uppercase. And he said, well, you know, you can just put on your caps key. She said, no, I shouldn't have to worry about caps. It should all be uppercase. And of course, she demanded this, And they finally put it in, and what it meant was they're building a database. So when the company tried to print out automated letters using this new nifty software, guess what? All the addresses and everything was in uppercase. So they had to put in code after the fact, convert it back to normal or sentence case. Huh?
Why didn't they just ignore the crazy?
Because she had power within the customer or company.
How many customers do they have with this software?
Well, the people actually using the software, it's really a small number of people within the company are using the software because they're doing this to actually maintain their database of medical personnel who they would place on an as-needed basis at various places. So you had a small number of people within this company, the customer's company, that were using the software to actually manage these people.